Okay, we're back on question number 34, and we're now going to look for the measure of arc ABC. Let's go ahead and highlight this. You can see ABC. If I highlight this, let's bring this around with a green marker. I'll try the best I can to stay on the circle. If you take a look at that arc, you can now see that angle, this angle right here, ADC, is actually an inscribed angle that intercepts this arc ABC. Intercept meaning it cuts it out of the circle. So what we have here is a relationship between an inscribed angle and its intercepted arc. And we know that if you take the value or the measure of the inscribed angle and multiply it by 2, you will get the measure of the intercepted arc. So for the measure of arc ABC, all that is 102, which is our measure of our inscribed angle, times 2, which in this case is 204. And 204 should be written as degrees because it's not specified in the actual question. So we have ABC is 204 degrees. The same process can be used to find the measure of BCD. Now I'm going to use blue, darker blue, to highlight this. We can see the difference. For arc BCD, we have that right here. So I'm going to go ahead and highlight that so you can see. Here is BCD. Let's darken that up a little bit. And you can see that BCD is actually the arc that is intercepted by, let's put this in red, by inscribed angle BAD. So inscribed angle BAD intercepts arc BCD. That means if we take the measure of inscribed angle BAD and multiply it times 2, we'll get the measure of arc BCD. So we'll go ahead and do that now. We found out that the measure of BAD was actually x, and x was 80. So that means the measure of arc BCD is actually equal to 80 degrees, which is the measure of the inscribed angle, times 2. That written down. And 80 times 2 is 160 degrees. So the measure of arc BCD is 160 degrees.